you're going to review with me today. You're going to review with me tomorrow. You're going to review with me on Tuesday. Okay. But then it's going to be a lot of like self-discipline on the other days. There is a packet in here that goes chapter by chapter. And then I will post one more that kind of has it all mixed in. This reference sheet will be given to you. So you're going to get the unit circle and you're going to get the law of cosines formulas. You can use a calculator, a scientific calculator. The whole test. Yep. No, I didn't. I just scribbled it.
I didn't know if I was...
If you got on me for every spelling error I'd ever have, we'd never get through a lesson. Scientific. Is that right?
I just thought I was...
Yes. Is that? I think that's how I wrote it. I just jumbled it. Yeah. Okay.
You started to do the I, but then you replaced it with an E.
Gotcha. Yeah.
So we use our iPads for the calculator?
No. Well, for the scientific calculator, sure. Yeah, I can give you the lockdown one. Yeah.
So wait, are we going to have... Oh, okay. Sorry.
Does that answer your question?
Yeah.
Okay. You will have it the whole time and you will need it for some things. You do not need it for everything, but you will need it for some things. So calculator is not an option. You do have to have it. And it cannot be a graphing calculator. So if you bring it that day, I will tell you you cannot use it. Okay. There are 36 multiple choice. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 11 open-ended, which most of those are the long ones, like your matrices stuff, and then the graphing is in there. It's been so very long, yes, that you've forgotten things. So this is like your systems of equations with 3 variable, your systems of equation with Gauss-Jordan or Gaussian elimination back substitution. You can choose between those two. Your Cramer's rule system, your partial fraction decomposition, the graphing of your conics. So we're talking parabolas, circles, ellipses, hyperbolas. Okay. And then the polar coordinates where you had to plot your coordinate point on polar, the rotation of the conic, and the polar graphs. So the circle, the rows, the limits on that kind of stuff. I will tell you, I'll narrow it down for those. Like once we get through those reviews, I will narrow it down so you don't have to study all of those, like all of the polar graphs. But you are going to see some through there. So some of those questions count for double. There's a total of 47 questions, but some of the bigger ones count for double, which is why it ends up being like out of 50 almost. Okay. So that's like the logistics part of it. Okay, so I won't see you again so Tuesday, I'll see you today, Thursday, Tuesday, and then I don't see you again till the following Monday, which is your review day. I know that there are some people that will you will come in on that day and they will say, just review your material. I will do things with you on that day. So if you are like contemplating getting to school on that day, do it. Come to school that day because I will do some additional review with you, okay? So your goal, I would say, by Tuesday of next week is to work on this packet. So the one that's there now. I am going to add the second packet so that C period has it. But you could wait if you wanted to until closer to your test. Have the second packet done by the Monday review day I see you so that I can answer questions on those, okay? This packet, it includes I'll put the Calc Chat link if I don't have it on there because it's the older book. I will put the Calc Chat link on here to check your odds, and then the evens are posted as well. So in that list of things that are posted in that review assignment, there's the packet that says even answers, which is this. It goes chapter by chapter. So basically I took the reviews and then I scaled back as to what would not be on your test. So these are modified from the actual chapter test reviews in your book. In chapter 6, which was law of sines and law of cosines, remember, I'm going to give you the law of cosines, but you need to know the law of sines formula. Okay. You will be given, so if it is highlighted on this paper, hang on. It says it here. If it's highlighted on this paper in blue, you will be provided that formula. If it is highlighted on that paper in pink, you need to know that formula. It is not included. So like the first area one, that 1/2, that's when you're given side angle side, 1/2, side 1, side 2 times the sine of the angle in between them. That is not given to you, so you want to make sure you know it. You will, yep, go ahead.
Highlighted?
If it's highlighted in pink, you need to know it. If it's highlighted in blue, it's given to you.
Okay.
Yep. You got to word problems with your law of sines and law of cosines. You're not going to see a lot of those, but you will see either one of law of sines or one of law of cosines, so you want to be prepared for each of those. 6.2 was law of cosines. Those are the formulas that were on that first reference sheet. I will give you those. Okay. And then the Heron's formula, the area formula, in which you have to add the 3 sides, divide by 2, that's your S, and then the square root of S times S minus A times S minus B times S minus C. That one is given to you on your test. 6, 3, and 4 were your vectors. So this started, you need to know your component form and your magnitude. So if I have coordinate point x1, y1, and x2, y2, and this is my initial, and this is my terminal, then the component form is x2 minus x1, comma, y2 minus y1. And then the magnitude, you can either use the distance formula, or you can do the square root of a squared plus b squared if you already have the component form. So that would be like 33 and 34. It's okay. Is the square root of x2 minus x1 squared plus y2 minus y1 squared. You're welcome. That's distance.
Can you zoom in?
Then you get into finding the sum of vectors. Yeah.
What was the distance value?
Okay, then we're adding, subtracting scalar multiple on vectors in both component form and the IJ format. Then you're finding the vector in the same direction. So this, you put the component form over the magnitude. That is, again, highlighted in pink, which means you need to know that one. The dot product comes up. So if it asks you to find the dot product of 2 vectors, we multiply the first term in each and then add it to the second terms. So if this is u1, comma, u2, and then v1, comma, v2, then we find the dot product by multiplying these two, u1 times v1, and then add it to the multiplication of these two, u2 plus v2. And it will be an individual number. Dot product is just one number. Okay, that's more dot product. Okay, angle between 2 vectors. This will be given to you. This is one that requires the calculator. So it's the dot product of the 2 vectors over the product of the magnitudes. And then we second cosine that whole thing to get the angle in between. That would be both 69 and 70. Okay, under 47, I want you to add if the magnitude, same set of directions, but if the magnitude, let's say, is 5 at the end. So the way that it is for 47, you're finding your unit vector. And unit vector means that it's a vector in the same direction, but it has a magnitude of 1. If it said it has a magnitude of 5, then you're going to do what you do for 47, but then you're going to multiply it by 5 at the end. You can actually cross out the rest of this page. So this, whatever page this is page 4 that page 3 that I'm on. You can cross those out. I didn't put the parallel, orthogonal, or the complex number with the trig form on there. So you can cross those out. Okay, then came chapter 7, and this was your systems of equations, your matrices, all that stuff. So the systems of equations, most of them are on the open-ended part because obviously you can otherwise just take your points and plug them in. So you're going to see them on that open-ended part. The multiple choice could be like the inverse of the matrix, which we'll get to in a second. But they will say, sometimes it will say solve using any method, and you can choose between elimination, substitution. But then there's going to be times when it says specifically solve using this method, so you want to make sure you pay attention to it. So that was 7-1. There, the word problems are in there as well for the break-even point and the supply and demand, all that stuff. 7-3 was your triangle systems. So this is one of the ones, like number 43 is one of the open-ended questions where you've got to work backwards. You'd start at the bottom and you'd work your way back up. 49, you'll see something like that, but it will actually tell you, I think the directions on that one will either say use Cramer's rule or the matrices on it. Yeah. 55 is your partial fraction decomposition. So remember with those, you want to factor out your denominator. Each term gets split up with an A or a B, and then you multiply by what's missing to figure out what goes in the place of the A's and the B's. So that was all 7-3. 7-4 was when we started the matrices. So on the review, there's one question that says Gaussian elimination with back substitution. This is your 1, 1, 1, 0, 0, 0, but the numbers here. And you work it into a triangle system and you use back substitution working from the bottom up. Or you can do Gauss-Jordan, and it literally gives you a this or that. You get that choice. The Gauss-Jordan is your 1, 1, 1, 0, 0 above and below. And then the answer's there. So there's no back substitution with Gauss-Jordan. But that question will give you the option. You can choose between them. Then you get into 7-5, which was adding, subtracting, and the scalar multiple on the matrices. And the multiplication on the matrices. So remember, these are the ones you want to know, the rows and the columns, so that you can fill each individual spot. 7-6 is the inverse of the matrix. So I would recommend using the shortcut, which is the 1 over the determinant. And then we switch the A and the D, and you negate the B and the C. And then 7-7 was actually the actual determinant. So this is that Jesus fish. So if it's A, B, C, D, we do the fish. We would do D times A minus C times D. That's for a 2 by 2. C times B, sorry. That's for a 2 by 2. And then the open, no, and then there's the determinant of the 3 by 3. So the 3 by 3, remember you rewrite the columns to the right of it. You multiply down, top left, bottom right first. You'll add them all together, and you get a number. And then you go back the other way, multiply top right, bottom left, add them together. You get a number, and then you would do the pink number minus the purple number. So whatever you get from the top left, bottom right, it gets that minus the other one. So you can take off the area and the collinear on 7-8. But Cramer's rule is another one of the open-ended ones. Actually, but it's Cramer's rule of the 3 by 3. So like this one.
So which one do we cross off?
The area and the collinear point one. This one, I think, is one of the ones that's worth 2 questions, too. Oh, no. That one's regular. So remember Cramer's rule, you find D by doing the X's, the Y's, the Z's. Then you do dx. Take out the X's and put in the constants, and then the Y's, and then the Z's. And then dy, you would leave the X's, take out the Y's, put in the constants, and then the Z's. And then dz, you would leave the X's, leave the y's, replace the z's with the constants, and then your x is your dx over d, your y is your dy over d, and your z is your dz over d. All right, then chapter 8, we got into our sequence and series, so hopefully this starts to feel a little bit more recent, okay? You'll have something like the first one where it's giving you, it's going to ask you for a certain number of terms in the sequence. You literally are just plugging those terms in. The next one asks you to find something recursively. So this is where you go one after the other after the other. 9 and 10 are your factorials. You're going to see factorials on there. 15 is your summation. So for these, you can literally take and plug in 1, plug in 2, plug in 3, plug in 4, and then add all the values together at the end. Eight two is your arithmetic sequences. Just adding the same thing to each time. There's a partial sum in there. 8-3 is the geometric sequences. So this is multiplying by the same thing each time. And then the summation for the geometric you need to know. So it's the finite geometric and the infinite geometric are both in pink. That's things you need to know. Eight four started your binomial expansion. Oh, I think I took that one off too. Hang on, sorry. You need to know the CNR, but I think I took off the expansion one. Yep, you can cross out 73. I took off the expansion one. And then you got to probability. So remember with these, you're trying to, in the beginning, you're just figuring out the number of ways things are possible. So this is like how many different combinations are there from a combination lock? How many different license plates are there? How many different, all that stuff. Those were all the number of ways something can be done. And then we got into probability, which was in 8-6. And this was, you have to figure out if it's an and or an or statement, remember? And if it's an and, is it independent or dependent? If it's an or, is it mutually exclusive or not mutually exclusive? So this is all like, that's where it started in 8-6. So an and, let's say an or statement, because that's where we started. You add the probability that the first thing is happening plus the probability that the second thing is happening. And then for these, you had to figure out if they're mutually exclusive or not. Like, can something be both? This is if it's mutually exclusive. Like an even or an odd, or a red or a black, or a red or a club. Those two things cannot overlap. And then not mutually exclusive would be the probability of the first plus the probability of the second minus the probability that both happen. So like a red heart, a red heart. It'd be the probability you get a red card, the probability you get a heart, minus the probability that you get a red heart. That's if it's an or statement. If it's an and statement, then you're looking to see if it's independent or dependent. If it's independent, which means one does not affect the other, for example, you take something out and you put it back, that would be independent. Or a randomly generated number from a computer, that would be independent. For these, we multiply the probability that the first happens times the probability of the second thing. And if it's dependent, meaning you took something out and didn't put it back, then it's the probability that the first happens times the probability the second happens, given the first already happened. and you got what you wanted. So if your goal is to pull 2 black socks out of a drawer, the first time you'd figure out how many black socks there are out of the total number of socks. And then the second time you would take away from not only the total number of socks, but also the black sock, because that's what you assume you got. Okay, then came 9, which was your conics. So in your conics, you've got your circle, your parabola, your ellipse, your hyperbola. Okay, this is already on the solutions page, but if you don't remember this stuff, I would rewrite it all out, okay? So the formula for, or the equation for a standard form of a circle is x minus h squared plus y minus k squared equals r squared, where hk is your center and r is your radius. For a parabola, there are 2 forms. It would be, if it's x squared, then, and it's a positive 4p, this would be a parabola that faces up. And then if it's a negative 4p, this would be a parabola that faces down. So it's x minus h squared equals 4p y minus k. And then if it's a y squared with a positive 4p, then it points to the right. If it's a y squared with a negative 4p, it points to the left. And p is the distance from the vertex to the focus, and the vertex to the directrix. Then you had your ellipses. So again, there are 2 different types of ellipses. Horizontal would be wider than it is tall, and that's when the x gets the larger denominator. So x minus h squared over a squared plus y minus k squared over b squared equals 1. A has to be larger, and c squared equals a squared minus b squared. And then on a vertical ellipse, which is taller than it is wide, it's y minus k squared over a squared plus x minus h squared over b squared equals 1. Order there does not matter. What matters is the bigger denominator is under the x for the horizontal and under the y for the vertical. And then you got hyperbolas. So this has the minus between x minus h squared over a squared minus y minus k squared over b squared equals 1. If it's horizontal, the x comes first and is positive. And then y minus k squared over a squared minus x minus h squared over b squared equals 1 is your vertical. So the horizontal means that your branches open to the right and to the left. And the vertical means they open upwards and downwards. A, again, A is first this time. Then c squared equals a squared plus b squared. And the asymptotes, if it's horizontal, k plus or minus b over a times x minus h. And if it's vertical, k is plus or minus a over b times x minus h. So the only difference there is the a over b and the b over a. So then in this, you get your review of circles, you get your review of parabolas, you get your review of ellipses. I did take off eccentricity. It's not there, so you don't have to worry about it. You get your review of hyperbolas all the way up to 49. Then you're identifying the type of parabola. So remember, if a times c is 0, it's a parabola. You're identifying your types of conics. If a times c is 0, it's a parabola. If a equals c, it's a circle. If a times c is a positive number, it's an ellipse. And if a times c is a negative number, it's a hyperbola. And then 59 and 61 are your rotations of your axis. So there are 2 questions on this, one where you just have to identify the angle and one where you have to full on rotate and graph it. This is that super long process that we did in 9.3. So the cotangent to theta equals a minus c over b is how you find the angle. And then the x, this part will be given to you. X equals x cosine minus y sine, and y equals x sine plus y cosine. You replace the x and the y with those, plug in the value for the theta, and then solve and put it into standard form. Then you're going to rotate your axis and then graph your conic. So this is one question, just finding theta, and one, the full-on rotation. And that's on the open-ended part, and that's worth 2 questions. 9-4 started your parametric. This is your T, like you're at this one, you would be plotting your points and then graphing. Then we got into actually eliminating the T so that you have one equation and finding the T equation when you only are given one of the parametric ones. And then you get to plotting your polar coordinate and converting into rectangular. That's on the open-ended part. Converting from polar to rectangular and rectangular to polar. And then 9-6 was graphing your your polar graph. So the only thing that is from chapter P is the quadratic formula. There's a question on quadratic formula. So x equals negative b plus and minus the square root of b squared minus 4ac over 2a. So you can skip 10-1, okay, the three-dimensional, and the spheres are not on there. And then for P, you could literally skip with the exception of the quadratic. Where'd it go? There's one quadratic on here, which is 83. You can do 76 using quadratic too. But that's the one you have to review from P. Everything else you can skip for chapter P. Yeah, like the rest of it, you can literally skip. There's one question from chapter P and it's a quadratic formula. That's it. No, like negative b plus or minus square root of b squared minus 4ac over 2a. No. Factor means like find the parentheses.
Well, yeah, but like if you can't factor, you put it.
Then you do the quadratic formula. Yeah, so it won't be factorable. So you
Okay,
have to do the
okay.
quadratic formula. Yep. All right, questions for me on like anything logistics related to your, or overall questions? You have to get started on this. If you're taking this exam, there's no way you can wait. You got to start. It's a lot of content. Yep.